What if the future was already here, and we buried it? Not in vaults or under lock and key, but in plain sight, pushed aside, papered over, or priced out of existence. The world we know today, paved with convenience and waste, might have unfolded differently if a few key decisions, some deliberate, others quiet, had gone another way. This isn't a story of conspiracies. It's a story of choices, of what was possible and what was prevented. Imagine a car made not of metal, but of plants. In 1941, Henry Ford unveiled a working prototype of a vehicle with a body formed from hemp-based plastic. 10 times stronger than steel and 1,000 pounds lighter, he demonstrated its resilience by swinging a sledgehammer against it. It didn't dent. This car ran on hemp ethanol. Its frame, fuel, and interior were all derived from the same renewable source. A vision of mobility grown from soil, not mined from rock. That vision faded into silence within a few short years. A 1937 law, pushed by industrial giants with much to lose, made hemp production economically unviable. The car was dismantled, the materials forgotten, and with that, a renewable, biodegradable, affordable alternative to plastics and metals vanished from the mainstream. But Ford's hemp car was only the beginning. Across the 20th century, discoveries emerged, technologies with the potential to reshape how we build, grow, travel, and consume. Each one shared a peculiar fate: initial promise, followed by sudden resistance, and then oblivion. A light bulb that could burn for a century, deliberately redesigned to fail. A public transportation network dismantled to sell more cars. Stockings engineered to tear, not last. Farms that could power and fertilize themselves, rendered illegal. A microscope that might have seen the invisible and then disappeared. None of these inventions vanished by accident. Their undoing came not from lack of utility, but from the gravity of economic interests. When an idea threatens to disrupt entire industries, the battle isn't fought in labs. It's fought in boardrooms, courtrooms, and regulatory halls. This documentary doesn't claim to reveal hidden truths. It offers something deeper, an invitation to revisit the past not as a fixed timeline, but as a series of roads not taken. Each chapter will begin with a moment, a scene where something remarkable flickered into being, and then, as quickly as it appeared, it was gone. Through these stories, we'll uncover a rhythm: discovery, suppression, silence, but also resilience, because even buried ideas leave traces. And sometimes they return. This isn't just about the past. It's about the choices we face now, about whether we continue to live in a world shaped by the lowest bidder or one molded by the best we can imagine. The stories that follow are not just reflections on what was lost, but on what might still be reclaimed. It begins with a simple question: what kind of world could we have built if we had chosen differently? It started with a hammer. In 1941, Henry Ford stood before a curious crowd, a sledgehammer in hand. Behind him gleamed the future, or so he believed. A prototype car with panels not made of steel, but of hemp-based plastic. Stronger than metal, lighter than fiberglass, and completely biodegradable. Ford swung the hammer into the car's door. It didn't dent. This wasn't a stunt, it was a statement. Ford had long dreamed of vehicles grown from the soil, not just powered by plants, but built from them. The car's body, interior, and even its fuel, hemp ethanol, came from the same renewable crop. 1 acre of hemp could produce 4 times the cellulose of trees, and it grew in a season, not decades. At the time, industrial hemp was a marvel of possibility. It could be spun into textiles, molded into plastics, and transformed into building materials. It held the promise of a biodegradable, regenerative future, but its success would have meant failure for others. DuPont had invested heavily in synthetic fibers, nylon, rayon, and early plastics derived from oil and coal. A world built on hemp would have rendered those investments worthless. Worse, the company's powerful allies had direct influence in Washington. The Secretary of the Treasury, Andrew Mellon, was a DuPont financier. His niece was married to Harry Anslinger, the head of the Federal Bureau of Narcotics. Under Anslinger, a campaign began. The distinction between hemp and marijuana blurred intentionally. Public fear was stoked with stories of crime and chaos. The 1937 Marijuana Tax Act didn't outright ban hemp. It made it prohibitively expensive to grow. Farmers were crushed by paperwork, fees, and legal threats. By the early 1940s, industrial hemp had disappeared from American fields. Ford's hemp car was quietly dismantled. Its vision lost. Meanwhile, DuPont's synthetic materials filled the vacuum. Nylon became the standard for fabrics and rope. Petroleum-based plastics overtook markets that hemp could have served with biodegradable alternatives. The decision to suppress hemp's potential didn't just alter the trajectory of agriculture, it reshaped the very materials of modern life. For decades, hemp remained misunderstood and marginalized. It wasn't until the late 20th century that its industrial value began to be rediscovered. By then, the world was swimming in plastic waste, but the industries born from suppression had grown into giants, making hemp's comeback an uphill battle. What if the most sustainable material ever cultivated had never been silenced? Imagine cities built from plant-based composites, cars that leave no trace, oceans free from synthetic debris. The consequences of that lost path surround us, in landfills, in legislation, in the very air we breathe. And yet, the story of hemp isn't just a cautionary tale. It's a reminder of how innovation can be undone not by science, but by power. Of how the answers we need may already exist, waiting, buried, beneath layers of forgotten policy and industrial fear. What other ideas have we buried to protect the past? A light that never dies. It flickers quietly in a California firehouse, glowing since 1901. The centennial bulb, still alive, still warm, has become more than an oddity. It's a symbol of what could have been, a world where things are made to endure, but endurance was never the plan. In 1924, beneath the sleek diplomacy of Geneva, the world's leading light bulb manufacturers convened under a single shared mission: shorten the life of the bulb. The cartel known as Phoebus wasn't about innovation. It was about control. Together, these companies agreed to engineer failure. Every bulb would now last no longer than 1,000 hours. Any company defying the rule would be fined. At the time, bulbs were already capable of lasting far longer. Some experimental models had burned for 100,000 hours. Edison's early designs with thick carbon filaments could easily shine for thousands of hours. Manufacturing had only improved since, but that was the problem. A light bulb that lasted a lifetime meant a customer who only bought once, and so durability became the enemy of profit. Phoebus enforced its mandate ruthlessly. Manufacturers had to submit bulbs for testing. If one outperformed the standard, the maker was penalized. Documents discovered decades later revealed meticulous planning, systematic reduction of filament quality, materials deliberately chosen to wear out, performance thresholds adjusted not by need, but by market strategy. The result? A whole industry aligned not around lighting the world, but around keeping it dim just long enough to sell again. This wasn't an isolated choice. It was the blueprint for an era. Appliances, electronics, textiles, each sector learned the same lesson. Planned obsolescence sustains the bottom line. Better to sell a toaster twice than to build one that lasts 20 years. The light bulb became both metaphor and mechanism. And while the Phoebus cartel eventually collapsed during World War II, its legacy lived on. The 1,000-hour standard had become an industry habit. Even today, modern LED bulbs, capable of lasting decades, are often designed with internal components that fail prematurely. It doesn't have to be this way. That century-old bulb in the Livermore firehouse wasn't magic. It was simply well made. Its thick carbon filament, protected and consistent, continues to defy time. Engineers today could recreate it. They could exceed it. But the question is no longer just technical. It's philosophical. What do we value more, progress or profit? Longevity or turnover? We've inherited a consumer world designed to disappoint us slowly. A world where brightness dims by design, where repair is harder than replacement, and where even the simplest object, the humble bulb, became a battlefield between durability and demand. What would it mean to design for the century instead of the cycle? And what else have we learned to let burn out before its time? It began with silence on the rails. In the early 20th century, America thrummed with the sound of electric streetcars. Over 100 cities pulsed with clean, efficient transit systems that ran on wires and vision. These were not clunky relics, they were the arteries of urban life. In cities like Los Angeles, over 1,000 miles of track stitched neighborhoods together. People could live, work, and explore without ever needing a car. Then, one by one, the wires were cut. Between the 1930s and 1950s, a quiet dismantling took place. A company called National City Lines, backed by General Motors, Firestone Tire, and Standard Oil, began purchasing electric streetcar systems across the country. On the surface, it seemed like modernization. In reality, it was elimination. Tracks were allowed to crumble. Maintenance was deferred. The systems, once symbols of progress, were declared outdated. They were replaced by diesel buses, manufactured by General Motors, fueled by Standard Oil, and riding on Firestone tires. It was a perfect vertical integration. But for the public, it was a loss disguised as an upgrade. The streetcars were faster, quieter, and cleaner than the diesel buses that replaced them. They didn't belch fumes or shudder on acceleration. They didn't break down as easily. But most importantly, they didn't require gasoline or tires. And that was the point. In 1949, the scheme was exposed. The companies behind National City Lines were convicted of conspiracy to monopolize the sale of buses and related products. But the fines were symbolic: $5,000 for General Motors. $1 for each executive. By then, it was too late. The infrastructure had been ripped out, the copper wires sold, the public depended on cars. Cities were redesigned around roads instead of rails. Suburbs sprawled outward. Smog thickened, commutes lengthened, and the dream of public transit became a faint echo. The tragedy wasn't just technological, it was cultural. America traded connection for congestion. The rhythm of the city, once powered by shared movement, was fractured into individual journeys sealed behind windshields. We often hear that people prefer cars, but preference is shaped by options and by what's taken away. Imagine a Los Angeles where you could glide from downtown to the beach without touching a steering wheel. Imagine an America where neighborhoods were built for walking, not just parking. That future was not lost to failure. It was taken deliberately, surgically, and profitably. The rails are gone. But the lesson remains. When infrastructure disappears, so does possibility. When public systems are privatized and gutted, the cost is more than money. It's mobility, equity, and quality of life. What would our cities feel like today if we had chosen tracks over traffic? And what might still be waiting beneath the pavement, dormant but not forgotten? The thread unraveled quietly. In 1940, women lined up across America to buy a revolution: nylon stockings. They were smooth, sheer, and astonishingly durable. Some wore the same pair for months. They didn't run, they didn't tear. They simply lasted. That was the problem. DuPont, the company behind nylon, had created a wonder material. Stronger than silk, resistant to wear, and cheap to produce. Their chemists had unlocked a future of synthetic textiles that didn't rely on delicate natural fibers. But within months of launch, they realized they had gone too far. If the stockings didn't wear out, why would anyone buy more? Quietly, the chemistry changed. Internal documents revealed a deliberate decision: weaken the fiber, reduce the denier, make them more fragile, more beautiful, and more disposable. A snag became a run became a sale. Planned obsolescence was born not in a factory, but in fashion. World War II paused the charade. Nylon was diverted to parachutes, ropes, and military gear. But when the war ended and stockings returned to shelves, something had changed. Women noticed the difference. The stockings tore more easily. They didn't last. DuPont offered no explanation. Instead, it launched an advertising campaign that normalized the fragility. Runs became part of the charm. Stockings were marketed as ephemeral, delicate, never mind that the same material, in other applications, could withstand battlefield conditions. The irony deepened over time. As synthetic fabrics advanced, garments designed for performance, athletic tights, compression wear, proved that durability was never the limitation. It was choice. We live today surrounded by textiles designed to fail. Fast fashion thrives on the same principle that reshaped nylon: low cost, high turnover. Not because the materials demand it, but because the market rewards it. Imagine a world where clothing is crafted to endure, where garments grow with us, not apart from us, where quality isn't hidden behind luxury price tags, but built into everyday design. We could have had that. We did, but when longevity threatens profit, even a miracle thread can be cut. What does it say about our values when we choose to design for decay? And how much waste have we worn in the name of style? It began with a circle, a closed loop. Nothing wasted, nothing wanting. In the 1970s, researchers quietly built a model that could have changed everything about farming. Waste became fuel. Fuel became fertilizer. Water cycled endlessly. Crops, fish, and animals thrived in symbiotic rhythm. A farm that fed itself. This wasn't science fiction. It was a practical system that worked. Livestock produced manure that fueled biogas digesters, which powered the farm. The digesters' byproducts became fertilizer. Food scraps went to animals. Water filtered through aquaponic beds. Every part of the system served another. The vision was simple: small farms, locally powered, nearly self-sustaining. And it was working. Then came the rules. Quietly and almost invisibly, regulations began to stack. Zoning laws separated animals from crops. Permits for biogas became prohibitively expensive. Feeding food waste to animals was deemed unsafe. One by one, the feedback loops were broken. Large agribusinesses didn't need to fear the technology directly. They only had to ensure it couldn't scale. And that's what happened. Self-sufficiency is dangerous to industries that depend on dependence. Fertilizer companies couldn't sell to farmers who made their own. Feed suppliers lost customers who recycled food waste. Energy utilities couldn't charge for farms that powered themselves. So the system was discredited, not with evidence, but with bureaucracy. Meanwhile, industrial agriculture grew. Fields stretched into monocultures. Chemicals replaced cycles. Farms became factories, and farmers became operators, tied to inputs, loans, and fragile supply chains. And the quiet farms, the ones with loops instead of lines, faded from view. But the principles never stopped working. In pockets of the world, farmers still build circular systems. Some use solar, some use fish, some use mushrooms or black soldier flies or methane tanks. The methods change, but the idea endures. That waste is not waste. That food can be grown with wisdom. That nature doesn't do straight lines. What would it mean if every neighborhood had a farm that powered and fed itself? What kind of resilience did we bury beneath a mountain of red tape. And who benefits when the simplest solutions are made the hardest to reach? It started with a lens no one else could see through. In the 1930s, a researcher named Royal Rife claimed to have built a microscope unlike any before it. It didn't just magnify, it revealed. Rife said his device could visualize viruses in real time, not with lenses, but with frequencies. By illuminating specimens with tuned wavelengths of light, he claimed to make the invisible visible. But Rife's ambitions didn't end there. He believed that the same frequencies that revealed disease could destroy it. Each microorganism, he said, resonated at a specific frequency. Match it and you could shatter it, just as a singer's voice can break glass. He called it the mortal oscillatory rate. In 1934, a clinical trial sponsored by the University of Southern California put Rife's ideas to the test. 16 terminal cancer patients were treated using his frequency generator. 14 reportedly recovered. Then the silence began. Labs were raided, equipment disappeared, medical licenses were threatened. Rife's name, once whispered with awe, became radioactive. Mainstream support evaporated. The technology was never subjected to rigorous peer review. It was buried before it could be. Some believe Morris Fishbein, the powerful head of the American Medical Association, tried to buy Rife's patents. When rebuffed, the story goes, he used his influence to dismantle the work. The truth is murky. No peer-reviewed studies confirm Rife's results. His microscope, which he said achieved magnifications of 60,000x, was never independently verified. But what stands out is not just the controversy, but the pattern. Instead of investigation, there was erasure. In science, bold claims demand bold scrutiny. But Rife's story wasn't one of skepticism. It was of suppression. A lab destroyed, not debated. A legacy reduced to rumor, not rebuttal. If his methods had been flawed, they could have been disproven. If his claims were false, they could have been tested. Instead, they were erased from the official record, leaving behind only questions. What if the treatment worked? What if it didn't? What if we'll never know? Because the choice to ask was taken away. In an age where billions are spent on pharmaceuticals and treatments, it's worth asking, what happens when the cure is too cheap, too simple, or too outside the system to be allowed? Not all forgotten technologies were miracles, but some were never given the chance to be. It began at a plastic recycling plant where nothing was supposed to be alive. In 2016, Japanese researchers were studying microbial life clinging to discarded bottles. What they found stunned them, a bacterium that didn't just live on plastic, it ate it. The organism, Ideonella sakaiensis, had evolved an enzyme capable of breaking down PET plastic, turning it into basic biodegradable components. Centuries of waste reduced to weeks. In lab conditions, the bacteria consumed plastic bottles in just 6 weeks. Further engineering of the enzyme made it work even faster, even at room temperature. The implications were massive. A living solution to one of the most intractable environmental crises on Earth. Then, oddly, progress slowed. Despite media buzz and brief excitement, research funding dried up. Partnerships vanished. Large-scale development never materialized. In an age overwhelmed by plastic, 380 million tons produced each year, the technology remained in obscurity. Why? Because solving plastic waste threatened more than pollution. It threatened an entire economic model. Recycling, for all its flaws, is a multi-billion-dollar industry. From collection to sorting to reprocessing, it employs thousands and maintains massive infrastructure. A bacteria that renders it obsolete? That's not innovation, it's disruption. And not the kind investors like. Worse yet, plastic isn't just about packaging, it's a petroleum product. Nearly 8% of global oil output feeds the plastics industry. If demand drops, so do profits. And when profits fall, influence moves. Regulatory hurdles quietly appeared. Funding was rerouted. Interest cooled. The enzyme still exists. Some labs are still refining it. But the global rollout that could have followed, the landfill inoculations, the bioreactor farms, the coastal deployments, never came. Instead, we doubled down on single use. Bottles and wrappers continue their slow decay in oceans and soils. Microplastics enter our food and lungs. The problem worsens, even as a potential answer waits. We often talk about saving the planet with big ideas, but sometimes the idea is already here, and we've decided not to use it. What if plastic waste wasn't permanent? What kind of world are we choosing to live in when we ignore the solutions right in front of us? The secret was beneath our feet all along. In the 1940s, soil scientists began to document something extraordinary. A microscopic network living within the roots of plants, thread-like fungi called mycorrhizae. These fungi didn't just coexist with crops, they enhanced them. They extended root systems, helped access water and nutrients, and protected against disease. This was nature's original fertilizer. In trials, crops grown with healthy fungal networks showed staggering benefits. Yields improved by 20 to 40%. Plants resisted drought, needed fewer pesticides, and thrived with minimal synthetic inputs. All it took was preserving the biological integrity of the soil. But this discovery posed a threat, because it suggested that industrial agriculture, dominated by chemical fertilizers, herbicides, and pesticides, might be unnecessary. Companies like Monsanto and DuPont, whose profits depended on the constant sale of synthetic inputs, recognized the danger. And so, instead of denying the science, they drowned it. They promoted farming methods that quietly destroyed fungal networks. Deep tilling became standard, tearing apart the soil's microscopic life. Monocropping deprived fungi of biodiversity. Chemical fertilizers and fungicides, ironically, killed the very fungi that made nutrients available naturally. Farmers, often without knowing it, were taught to sterilize the living soil they depended on. Agricultural colleges, funded by chemical giants, emphasized synthetic solutions. Extension agents taught farmers to rely on inputs. Over time, generations of growers were trained to believe that without chemicals, their fields would fail. And so the fungi disappeared. Not because they didn't work, but because they worked too well. By the 1980s, soil health was no longer a topic. The biological complexity of Earth had been replaced by formulas. NPK, nitrogen, phosphorus, potassium became the religion of yield. But beneath the surface, the soil was dying. Today, regenerative agriculture is slowly reviving these ideas. Farmers are rediscovering cover crops, no-till methods, and soil inoculation. Yields are returning. Chemical use is dropping. But the path back is steep. Imagine if we had embraced the soil's intelligence from the beginning. How much land would be healthier? How many rivers would be cleaner? How many farmers would be freer? Sometimes the most advanced technology isn't new at all. It's ancient. It's alive. And we paved over it in the name of progress. It began with a balloon. In the 1970s, engineers devised a way to build a house in a week. The method was as simple as it was revolutionary. Inflate a giant form, spray it with durable foam, and let it harden. The result? A seamless, insulated, disaster-resistant home, completed in days, not months. It was called monolithic dome construction. A shell so strong it could survive hurricanes, earthquakes, even fire. It required fewer materials, less labor, and less energy to maintain. A crew of 3 could build an entire home in under a week. The dream was tangible, affordable housing for everyone. Then came the resistance. The construction industry, built on traditional methods, supply chains, and union labor saw the threat immediately. A building process that didn't need wood framing, drywall, or armies of workers? That was bad for business. So codes were written. Building regulations suddenly required framing inside foam walls, defeating the point. Fire resistance standards were tailored to favor conventional materials. Insurance companies denied coverage. Zoning boards delayed permits. The system didn't reject the innovation directly. It suffocated it with conditions. Labor unions opposed it too, fearing job losses. Suppliers of lumber, insulation, and roofing materials lobbied against its use. Research suddenly surfaced claiming potential issues with off-gassing or long-term wear, none of which held up against real-world examples. But it didn't matter. The momentum was broken. Only a handful of foam homes were ever built. Those that survive today report remarkable performance. Near zero energy costs, minimal maintenance, exceptional durability. Yet the technology remains niche, buried under a tangle of regulatory and financial obstacles. And so housing remains slow, expensive, and vulnerable. Builders use the same methods they did a century ago because those methods keep the right people paid. We talk about a housing crisis, about affordability, about disaster resilience. What if the solution was invented 50 years ago and shelved? How many families live in fragile, overpriced shelters today because the better option was deemed too disruptive? Innovation isn't always about what we can create. Sometimes it's about what we're allowed to build. It started with a milk bottle. In the 1980s, a consortium of European companies designed a packaging system that turned waste into circulation. Every container, whether for milk, soap, cereal, or pasta, was built to last, not to be thrown away. Customers paid a small deposit. When they returned the empty package, they got the deposit back. The container was cleaned, refilled, and reused. Simple, efficient, proven. Pilot programs showed waste reduction of over 90%. Packaging costs for manufacturers dropped after the initial investment. Consumers liked the system. Municipalities saw landfill volumes shrink. Environmental groups praised it as a breakthrough. So why didn't it spread? Because it threatened too many empires. The packaging industry, makers of single-use plastic, cardboard, foil, and glass, stood to lose billions. Entire supply chains existed to support the throwaway model, from petrochemical companies producing raw plastic to logistics firms moving single-use goods to the recycling industry itself. Everyone depended on waste, and this system made waste obsolete. The opposition was subtle, then strategic. Advertising campaigns warned of hygiene risks from reusable containers despite data proving their safety. Lobbyists pushed for regulations that required extensive tracking and liability burdens, making the system more expensive than it needed to be. Retailers resisted the logistical complexity of collecting returns. Even cities joined the resistance. Many had spent heavily on recycling infrastructure. A new system that made that investment irrelevant? Politically unacceptable. Soon, the reusable packaging network, once poised to change the world, was stalled. It exists today only in fragments. Bottle return systems in a few regions, reusable grocery bags, niche refill stores. The comprehensive vision never scaled, not because it failed, but because it worked too well. Now, oceans fill with plastic, landfills overflow, and we continue to manufacture trillions of disposable containers every year, many for products used once and tossed. We tell ourselves it's complicated, that change is hard. But we had the solution 4 decades ago. We just chose not to use it. What does it mean to invent something so good that it must be stopped? And how much longer can we afford to throw away what we already know how to save? It started with a question. What if everything we throw away could grow back? In the 1930s, A single plant may have held the answer. Hemp, stronger than steel, lighter than fiberglass, and entirely biodegradable. But hemp wasn't just about fiber, it was also about cellulose. And cellulose meant plastic. Henry Ford saw it clearly. He built a car body out of hemp plastic and fueled it with hemp ethanol. A vision of mobility born from agriculture. In his mind, farms would grow the materials that once had to be mined or synthesized. Entire cars, frame, fuel, fiber, could emerge from the earth, not the refinery. It was real. Film footage shows Ford swinging a sledgehammer at the hemp car's fender. It doesn't dent. But this wasn't just a car. It was a threat. DuPont, then rising in power, had invested heavily in synthetic materials, nylon, rayon, and plastics derived from coal and petroleum. The rise of hemp-based alternatives jeopardized everything. So did the chemical cellulose industry. If farmers could make plastic, the industrial monopoly would falter. In 1937, the Marijuana Tax Act imposed complex, costly regulations on all cannabis-related crops, including hemp. The law, promoted with sensationalist propaganda, made little distinction between psychoactive marijuana and industrial hemp. It didn't ban hemp outright. It just made it impractical. Behind the curtain, connections abounded. DuPont's financial backers had close ties to federal agencies. Andrew Mellon, Treasury Secretary and DuPont financier, was uncle to Harry Anslinger, the head of the Federal Bureau of Narcotics. Anslinger launched a media campaign conflating hemp with narcotic marijuana, igniting public fear. By the 1940s, American hemp cultivation had been all but extinguished. Ford's hemp car was dismantled, the technology abandoned. DuPont's synthetics rose unchallenged. The petrochemical age flourished. And the plastic era began, not biodegradable, not renewable, and not designed for return to the earth. We buried a plant that could have reshaped industries, one that could have reduced plastic pollution, minimized agricultural dependency on oil, and empowered rural economies. Instead, we built a world of disposability. What if we had chosen differently? What if our materials didn't last forever in landfills, but returned quietly to the soil? The future was growing in the field, and we cut it down. It ended where it began, with power. Each of these discoveries, these almost futures, shared something in common. They didn't fail because they didn't work. They were buried because they worked too well. A house built in a week. A farm that fertilizes itself, a plastic that breaks itself down, a bulb that shines for a century. A car grown from the soil. None of these ideas disappeared on their own. They were suppressed not by science, but by systems. Not in some shadowy conspiracy, but in the slow grind of legal frameworks, market incentives, and institutional fear. A house that doesn't need constant repair undermines the construction industry. A crop that replaces oil-based plastic threatens petrochemical profits. A discovery that makes products reusable removes entire supply chains. Innovation, when too effective, becomes dangerous, and so it is slowed, regulated, discredited, not by evidence, but by influence. We like to believe that the best ideas win. That truth, when discovered, rises. But the history of invention tells a more complicated story, one where power often shapes what's allowed to succeed and what's allowed to disappear. This isn't about villains, it's about inertia, about how industries, once built, resist change, even if that change means a better world. It's about how systems protect themselves. The cost of that protection is all around us, in our landfills, our energy bills, our traffic jams, our polluted fields. It's in the oceans of plastic, in the flickering light bulbs, in the fragile threads and broken transit lines. But buried within all of that is possibility. These weren't lost technologies. They're paused ones, waiting for us to remember, waiting for us to decide that better isn't the enemy of good enough. So the question isn't just what we could invent, it's what we're finally ready to allow. We come to the end not with answers, but with a mirror. What we've seen isn't a list of inventions. It's a portrait of possibility, interrupted. A pattern where human ingenuity rises, only to be shadowed by human systems too invested in staying the same. A better bulb, a cleaner car, a farm that heals itself, a plastic that disappears instead of persisting for centuries. None of these were fantasy. They were real, proven, demonstrated, and then sidelined, not because they failed, but because they threatened to succeed too completely. Across these 14 stories, one truth echoes louder than any single invention. That discovery alone is not enough. What matters is what we do with it, what we allow, what we support, what we protect. History doesn't just remember the victors. It forgets the alternatives. And often, those forgotten paths could have shaped a healthier, more resilient, more compassionate world. But it's not too late. Some of these ideas are returning. Hemp is being reconsidered. Soil regeneration is finding new champions. Electric transit is rising again. People are asking questions, demanding choices, challenging the systems that once shut down what worked. We have the tools. What we need is the will. The battle is not in the lab. It's in the boardrooms, the courtrooms, the classrooms, and the dinner tables. It's in the quiet decisions that determine which innovations are nurtured and which are left to rot. So ask yourself, what kind of world are we building today? And what kind of future are we willing to fight for? Not with outrage, but with clarity, persistence, and memory. Because the next suppressed discovery might not be buried. It might be right in front of us, waiting. And this time, maybe, we'll choose to see it.